It's Mike here with High Intensity Health. As always, I'm grateful that you're here. In this live session, we're going to talk about the many ways that exercise helps your body's immune system. And this is important with regards to what's going on right now, with regards to the C word, the KahRona. But it also has to do with the incidence, the prevalence, and the severity of non-communicable diseases. Such diseases include, but are not limited to, things like autoimmune diseases, things like cancer, things like cardiovascular disease, things like diabetes and obesity. All of these diseases kill millions of people annually here in the United States and in many other countries throughout the world. So everything that we're talking about are relevant and contextually appropriate for the non-communicable diseases, as well as the infectious diseases that are posing significant public health issues for many people throughout the world. So thank you for letting me know that there were some audio issues. So number one, we know that exercise can reduce the prevalence and the severity of chronic conditions. So we know that chronic conditions, we've talked about this before. We know that the current public health issue that starts with the C is exacerbated by the prevalence of and widespread prevalence of chronic conditions. The hypertension, the diabetes, the prediabetes, the obesity, all of these chronic conditions make you more susceptible to having poor outcomes if you get infected. So number one, that's the way that exercise is protective. Number two, exercise helps to mitigate inflammaging. Whoa, inflammaging? What the hell is this? So as you age, you naturally become more inflamed. I mean, who knew this? So you take two people, same diet, same everything. Sally Smith is 27-year-old, and then Susie Smith is 57. Susie, even if she does everything right, will naturally have higher levels of baseline inflammation. We know that baseline inflammation is a problem when it comes to the C word, because there's a lot of autoimmune-like collateral damage. And the more that your bucket of inflammation is filled up, the more challenges are going to ensue. So inflammation, chronic inflammation, is ameliorated by exercise. So that's the second major way that exercise is very protective. The third major way that exercise is protective against every non-communicable disease that you could suffer from, and from this acute infectious that we're all acute infection that we're all dealing with, is that exercise helps to prime your immune system, and it helps to reduce age-related immunosenescence. So as you age, your immune system naturally functionally declines. This is known as immunosenescence. Exercise might help offset that. And number four is exercise helps to make your body more primed to have a better vaccination response. So if you're into getting vaccines, whether it's, or let's just say your employer makes you get a vaccine. Let's say you're a student. Let's say you work in a healthcare setting. You are forced to take vaccinations. And so you want to make sure that those vaccinations are effective. So that's what the data clearly shows. So here's a really good image that kind of talks about this, the benefits of exercise, severe course of COVID-19 and all this sort of stuff. And exercise is sort of the shield. So there's a lot of benefits here. We can, really dive into all of this, from upper respiratory tract infection to the influenza vaccination response and all of that. But let me just give you some specifics here. I think this is really interesting. If you look here at upper respiratory tract infections and you look at the severity in people that exercise versus people that don't, there's a dramatic reduction in the prevalence and the severity of upper respiratory tract infections in athletes compared to people who don't. This was just looking at T cell function. Now, T cell function is something we're going to talk a lot about, and this is being talked a lot about it in various scientific articles looking at T cell immunity and the prevalence of this, and why T cells and having functional T cells are important. And what you'll soon learn here, as we talk more about this throughout today's conversation, is that our T cells are influenced by our diet and our lifestyle. And our T cells are influenced through epigenetics. Our epigenetic system, we know that the software that's running our genomic hardware is influenced by way of the epigenome influences that, and our diet influences our epigenetics, and your T cells are highly malleable when it comes to epigenetic programming and imprinting and all of this sort of stuff. So that's kind of interesting. So let's get into some of that. Here's just some more data here in women. I know a lot of you are men, and you're like, okay, cool. Studies are done in men, but half you, at least according to YouTube analytics, are females, and you want to get excited about studies done in females. So here's some exciting studies done in females. People who regularly walk, this was one study, found that the incidence of an upper respiratory tract infection is only 8% in this cohort of women of over 50 individuals I think this was at Duke University, compared to 50% of sedentary controls suffered from upper respiratory tract infections. So staying inactive is not good for your immune system and just preventing the common cold. Okay, let's dive into exercise intensity. Now, a big thing that we need to kind of understand is exercise intensity is where we kind of get the benefits of this. And we're going to unpack this a little bit further. But first, I would like to dispel a myth. There's a myth out there that exercise is somehow bad. Some people are like avoiding exercise because they think it's an immunosuppressant or it's inflammatory. So let's kind of unpack that. Now, prolonged or excessive high intensity exercise can certainly make you more vulnerable to illness. Okay, so we need to understand exercise in context. So we know that athletes, as they're preparing for a competition or a major event, when they're doing high volume, can be more susceptible to getting infected. So excessive volume and excessive intensity is not good for your immune system, but a moderate and or periodic short duration high intensity is 2 thumbs up. So that's what we need to understand is there's kind of this J-shaped curve. So just because we're talking about how exercise is favorable, that doesn't mean that you go out and exercise all day. There's a sweet spot, and that's what, hopefully with a trainer, with some coaching, you can figure out what that sweet spot is for you. So you certainly can overdo it, and that's something that we need to understand. Okay, we'll talk about the vaccination stuff in a moment, but what I would like to kind of pivot to is this study right here. I know some of you love the scientific jargon and the details, and then we'll finish off on some of the protective effects of exercise when it comes to a vaccination. But first, let me just kind of share with you a hypothesis. This is something we presented on March 31st of this year, and that is one reason why individuals are susceptible to the coronavirus has to do with the fact that they have an accelerated aging of their immune system. And we'll further expand on that hypothesis and say that individuals who are susceptible to the virus have metabolic derangements, and these metabolic derangements are not just limited to their classical metabolic compartments of their body. They have metabolic derangements within their immune cells. And this study actually showed just that there's dysfunctional metabolic programming in their T cells. Now, small plug, we talk about this a lot in my book, Belly Fat Effect, that I wrote back in 2014. If you want to dive into it, you can check that out. But to think that you'd have metabolic dysfunction just in your liver or just in your muscle tissue or just in your fat cells is just myopic thinking. If you are insulin resistant, if you're pre-diabetic, if you have a lot of chronic inflammation, you probably have metabolic dysfunction in your immune cells as well. And this study actually showed that. So looking at mild cases versus severe cases, this is what this article actually found, is that there is a altered ability of GLUT1 transport protein. So we know that the GLUT1 transporter is how you get glucose into your cells in your tissues. And within the T helper cells, there was an imbalance in this GLUT1 transport protein. So basically, we know this to be true in mild cognitive impairment, in dementia, in Alzheimer's, where there's this functional inability of the neurons in various brain cells to get energy from glucose. And it appears that in metabolically exhausted T cells, this is also the case. So this is quite fascinating that there could be this ability and or inability of T lymphocytes to get energy. And more importantly, let me share with you this image right here, which actually shows this is comparing differences in gene expression profiles in mild cases versus severe cases. And what you're going to pay attention to here is the down regulation in gene regions that are involved in very important critical mitochondrial functions in T helper cells. Okay, so this is in the T lymphocytes themselves. There is alterations in various mitochondrial factors. So we're looking at oxidative phosphorylation, which is the end process of making cellular energy from the food that you eat. You see alterations in all sorts of NADH dehydrogenase complexes, which is involved in again, getting the electrons from the food that you eat to make cellular energy. There's all sorts of aspects in the complex 1 assembly in the mitochondrial chain and so forth. So essentially, what this paper is showing here is compared to healthy controls or mild cases, people that had severe disease had pre-existing mitochondrial dysfunction in their immune system cells. Really fascinating stuff. Now, I know this gets into the deep end. It gets a little bit nuanced and complex, and I'm not trying to lose you at all with the complexity. But I think it's an interesting thing to keep in mind. And let me draw some parallels here. We know that if you have intestinal permeability and porous barriers within your intestines, you might also have porous barriers throughout the body. For example, your lung barrier, the endothelial barrier. We know people with leaky gut have leaky blood-brain barrier. So there's, these tissues and the organelles and the various metabolic machinery that comprise and help the functionality of these different tissues are conserved throughout different organ systems. And so if you have mitochondrial dysfunction in your muscles, mitochondrial dysfunction in your liver, mitochondrial dysfunction in your fat tissue, it stands to reason that you might also have mitochondrial dysfunction within your immune cells and have T lymphocytes that are mitochondrial dysfunctional. And so some interesting things here. Severe COVID-19 might result from metabolically dysfunctional immune cells. So that's being talked about here. Now, let's also read to you something that's really interesting that I think you would find quite fascinating. Our data reveals the presence of population of H3K27ME3 CD4 cells. Okay, so CD4 cells are characterized by their epigenetic profiles. And so again, everyone's immune system is different based upon the epigenetic influence, which of course is influenced by their diet and lifestyle choices. So to think that everyone has the same kind of immune potential is just short-sighted. It's not scientifically accurate. So we can now epigenetically characterize our immune system, and we now know that in severe cases, these individuals have an epigenetically imbalanced immune system, which is quite fascinating. So these cells express low levels of GLUT1, the glucose transport necessary to support glycolysis during effector responses. Interestingly, we observed parameters indicative of mitochondrial dysfunction and apoptosis signaling in these cells, including altered mitochondrial ultrastructure and release of mitochondrial coenzyme C into the cytosol. So really interesting stuff here. Again, just showing that there's mitochondrial dysfunction within the immune system. And I would encourage you to check out these papers. Really, really fascinating stuff that it could be now that the virus is inducing mitochondrial dysfunction in these subjects. So that's one hypothesis. The other hypothesis is that these individuals had pre-existing mitochondrial dysfunction as a result of years of poor lifestyle and diet choices, and therefore they were more susceptible to having viral induced changes in their mitochondria. So whatever the case, it's really interesting stuff. But first, before we go on, friends, I want to let you know that these videos are brought to you by our very own Myoscience Nutrition. This is a product line that I created to help people like you optimize their sleep, optimize their recovery from exercise, and get more out of their intermittent fasting and therapeutic lifestyle changes. So we have a great promotion going on now through Tuesday where you can save on some really unique ingredients, natural compounds like berberine hydrochloride, like myo-inositol blended with L-theanine, GABA, magnesium, and taurine. We have a range of different formulations over on our website, myoscience.com. That's MYOXCIENCE.com, where you can save on a lot of science-based and third-party tested formulas using the coupon code HURRY17 at checkout over at myoscience.com. So a lot of interesting stuff. First, I just want to check in. How are we doing with some of these these concepts. Are they interesting? Josh Webb, thanks for being here. We have Dark Blade 27. Yeah, I mean, I think this is, some people might think that this is complex. I think the nuances and the details are certainly complex, but the big home applications, I think, are quite simple. We need to stay physically active. Now, I do just want to read to you a quote here as we kind of finish off here on the fact that exercise is involved in supporting the body's immune response to vaccination. So what we need to understand is that exercise induces acute inflammation, but that's adaptive. So let me just read this to you. This well-known activation of inflammatory pathways invoked by a single bout of exercise makes it almost counterintuitive that regular physical exercise would serve to reduce chronic inflammation. However, it is now evident that an acute inflammatory response plays a major role in the training adaptations observed in exercised muscles. Contracting skeletal muscle produces and secretes several cytokines known as myokines, most notably interleukin-6, which mediates metabolic changes during exercise. Interleukin-6 released from muscle increases up to 100-fold during contractile exercise, and its production results in increased systemic anti-inflammatory cytokines, and so forth. There are also data to suggest that the exercise-induced increase in interleukin-6 inhibits TNF-alpha production in the presence of low-grade inflammation. So again, we know that exercise does increase inflammation, albeit transiently. This is not permanent. This is not chronic. This is a transient increase in inflammation that is necessary and adaptive. Just like when you fast, that does induce a transient increase in, guess what? Stress. But it's not persistent. It's a transient increase in stress. Those transient increase in the stress-related hormones are adaptive. They help you mobilize fatty acids. They help you make ketones. They do a lot of different things. And it looks like my camera actually just went out. So what we're going to do is continue to talk about this and specifically hone in on the response to a vaccination. So this is data looking at older individuals, and what you're going to see here is 6 weeks and 6 months after a vaccination. This was for the influenza vaccine. There was a statistically significant increase in the exercise group that is in terms of their seroprotection or the protective antibody release after exercise. So friends, if you're going to get a vaccine, whatever vaccine it is, make sure you exercise concomitantly around that vaccination. So really important stuff here. And there's actually another study that we're going to dive into just looking at walking. Walking was associated with an increase in protective effects of vaccination. So this was this study right here. The title of this is Vaccination Response Following Aerobic Exercise. Can a brisk walk enhance antibody response to pneumococcal and influenza vaccination? And here's the images here, looking at the post-vaccination antibody rise in you have the baseline, and then they gave the same second booster vaccination 4 weeks later. What you're going to see here is a very significant increase in the IgG antibodies to this pneumococcal vaccine. So this has been known for a long time. There's many healthcare worker studies where individuals work in a healthcare type setting have to get a vaccination. They're overweight. They didn't get initial protection from the vaccine. And so what they actually did was then lose some weight. They underwent some therapeutic lifestyle change. And guess what? They had a more protective effect from the vaccine after that. So there's a lot of data here, friends, to support this. We know that exercise primes the immune system. So again, just to quickly review for those of you that are still here with us, and I want to thank you for being here live. Let's just kind of review. Number one, exercise helps to reduce the chronic conditions that are linked with losing quality life years. So if we think about many aspects of longevity, we know that longevity can be cut short by having heart disease, by having prediabetes, diabetes, autoimmunity, depression, obesity, cancer. Okay, these are the common things that kill many people throughout the world. And so just by regularly exercising, you can reduce your risk of those different conditions. And we also know that exercise can help to reduce and minimize inflammation, which is the age-associated increase in baseline chronic inflammation. So The older you get, this is all of you, okay? It doesn't matter your age. The older you get, the more inflamed that you're going to get. This is known as inflammaging, and exercise has been shown to mitigate that, okay? So those are the two things. And I think thirdly, and almost more importantly, exercise has been shown to prime the immune system and augment what's known as immunosenescence, and that is the functional decline of your immune system. So again, I don't know why we're not recommending walking. Why aren't we prescribing walking, prescribing hiking, prescribing push-ups? All of these things can be super helpful, friends. So make sure that you spread this message that exercise is so important. And for those of you that are interested in getting a vaccination, whether it's a pneumococcal vaccine, rhinovirus, hepatitis, or a coronavirus vaccine, we know that intense walking and exercise in general can improve your body's response to a vaccine. So exercise is essential business. There's a lot of great studies here. What I'm going to do is synthesize all of the articles that we I've been talking about today and put this in a blog post so that you have access to these references. I would like you to be able to share these with your friends and family and let them know that they should be moving, especially if they're sitting around and kind of twiddling their thumbs waiting for a vaccine. I know a lot of people are sort of kind of putting their lives on hold until there's a vaccine. And we really need to know that you may not get all of the health benefits from the vaccine if you're not regularly exercising. So, as always, friends, it's really great that you're here sharing this message, that you're here studying this research. I think this research is really important. And if you're enjoying this content, please hit that like button. If you're listening over in iTunes and you enjoy this content, I would be so honored if you could pay it forward with an iTunes review. That really, really helps us and helps people like you who are interested in learning more science-based ways to optimize their health. And we will catch you on a future video down the road. Before I leave here, I will address some questions. Ruth says, thank you for sharing this important information. Ruth, it is my pleasure. What else do we have? We have Robert here, and we have Spive21 as always. Thanks for being here, Spive. We have John. What's going on, John? We have Richard. So friends, as always, grateful that you were here. Thanks for sharing this message. And remember, exercise is essential business, and exercise is essential to immune system health. Okay, we will catch you on a future live down the road. Bye now.